All right, I think I should start. Good afternoon, everybody. I am Arghya Kusum Das, and I am from University of Wisconsin at Platteville. I am an assistant professor there. Regarding regarding my background a little bit, my research interest is mostly like big data analytics and artificial intelligence and that part. And I also enjoy like the data engineering, data infrastructure, and all those parts. So today I am going to describe Onstitute, which is a new online education platform for innovative data education curriculum. And I'm also going to describe how am I doing all these things and what are the students' experience in our university and all these things. I will try to finish the presentation by 20-25 minutes, and after that we can have a question answer session. If you have any, I'll be happy to answer. First of all, let's start with a brief background of what is the current state of data science education. So one of the major focus for the data science is like data science is creating lots of jobs. Data science is making more money for the people and all these things. But at the same time, there are some revolution happening in terms of education in data science also. So these big data, artificial intelligence, high performance computing, they are actually changing the domain of education also. And honestly, nowadays, this AI and big data education has become a huge market. So let's analyze, let's see what is the current state of data science education here. So if we look at the domain of big data analytics and everything, we can broadly classify this domain into three major different domains. The first one is programming models like MapReduce, graph processing, NoSQL. Then there are some analysis type like batch analysis, stream analysis, and all those things. And finally, we have something like these different types of hardware. Let's say these disk-based and in-memory and all these things. So what is happening if you take any of these combination, there is a new technology being proposed every day. For example, like MapReduce, batch analysis with disk-based computing, that means the Hadoop framework. Let's say these NoSQL, interactive query or interactive query in memory, that is let's say Redis. So lots of different things are being proposed, and on top of that there are lots of performance analysis tools also which are being proposed every day. So how to keep up with all these technology changes, this is really a hard job for any instructor. So the next thing is not only these big data analytic things, there are a huge revolution in terms of artificial intelligence. There are this is not only confined into traditional machine learning. There are deep learning, statistical learning, transfer learning, and so on and on and on. And furthermore, there are revolution happen in terms of high performance computing. So there are several things that have been improved, like CPU speed, GPU flops, IO performance, memory performance. Lots of things have been changed. And not only that, there are different types of cluster architecture based on the business demand have been proposed, like supercomputing cluster, cloud-based cluster, commodity cluster, what is scale up, scale out, lots of different things have been proposed. Now if we just try to look at the mode of education, how to teach all these different technologies and different things, we will see that, okay, the traditional offline mode is still there, like this synchronous face-to-face learning and everything. But there is some problem in traditional learning. There is it totally depends on the personal interest of the instructor. If the instructor is not a up to the change, then the learning curve will go down. And then there is limited collaboration opportunities. Also, there are like other staffing and admin issues, like universities cannot invest just like that for a computing infrastructure, or they cannot hire many people at the same time. So those are the problems for offline. Although online have the online education have alleviated some of these problems, but still these things are really like most of these online courses are like very much lecture heavy. So that means there is not much proactive interaction between teachers and students, not much of hands-on, and also like many people are like skeptic about ability to apply the skills learned. And also there is some it's like in terms of data education, there is a comment like there is a low investment on return. And also there is some kind of like hybrid mode of education where students can get access to many different resources. They can talk to the instructor, but still when it comes to the real big data or AI education, the question is it enough? Where is the infrastructure part and all these things? So the question is how to evolve, how to change your educational infrastructure, how to design the course, or rather what is the way out to evolve the education with the technology changes, or like let's say how to bring the HPC infrastructure into education in a cost effective way. So this to answer all these things, a collaborative infrastructure or a collaboration is extremely important. So that's what I am going to discuss in here. So first, let us discuss about the issues and challenges in the online data related courses. First, there is a course structure related issues. Courses are like very much lecture heavy and fewer or trivial hands-on. And also it is very hard that where to focus on, how to teach for a fundamental data science course or something like that, whether you should learn TensorFlow, whether you should learn PyTorch, and how to manage all these things, how to take care of the learning needs of the students. The second one is the infrastructure related issues. In the online mode, of course, there is virtual lab experience and all these things, but UI experience does not feel like real world. Many times you will work on some kind of, let's say, the web-based C++ compiler or web-based Python compiler, something like that. But when you move to industry and when you start working in the real infrastructure, that experience is totally different sometimes. And in some of the universities, they really do not have the infrastructure, back-end infrastructure even, not only university, some small companies and everyone, and not the great infrastructure is accessible to all. So there is a problem with the course infrastructure also. So as a result, what we can see is if it is an online or whatever mode of education, learning in the first place, it is very nice when it comes to the theory part and all these things. That learning part is excellent, but in the end, when the practical learning come into picture, it is very poor. And at the same time, we can see that there is lots of students are enrolling for different types of data courses available over internet, but there is a very big issue in terms of student retention. So how to take care of all those things that I will discuss about in this presentation. So the thing that we have to focus really on is a collaborative mode of learning. Like collaborative solution means I'm not talking only about like collaborating with one or two industry partner and like that, but what I am trying to say is a unified learning solution or an entire ecosystem which can nurture and improve the collaboration experience. So if we see the traditional experiences so far, we can see that the entire ecosystem was confined into the first two parts, like the learning solution and the software or middleware, because there are like very few infrastructure. I mean, most of the things were like all the software, they have like Windows support, they have like Linux support and all these things. And there were not much variation in terms of HPC platform, or there was not much of the software being proposed to address some specific issues. So all those things were there. So in terms of choice, there was some limitation. But in the last few years, if we look back, then we will see there is a revolution happen. Every day new technologies are being proposed, and not all the technology supports all the different types of infrastructure. They have dependencies. Someone performs on Linux, some performs on Windows, some performs better on IBM Power 9, some are developed for NVIDIA, like these P100 GPU, something like that. So we have to take care of all these things. And not only that, at the same time, there are demands from different students. Different students have different types of demands. Someone is just interested in learning, let's say, the machine learning parameter tuning. That student just are targeting for that type of job for the career. And some students are actually focusing on data engineering and need to know more about the infrastructure, configuration, and all these things. And there are some folks who really need some advanced, need to know some advanced stuff. So how to deal with all these things? So there should be like in the collaborative infrastructure, the courses should be divided into like 2 or 3 different structure, 2 or 3 different levels. So in the 100 level, the students may learn like the inception and histories, components, building blocks, application, and start on like coding on pre-configured infrastructure, something like that. And then on the next intermediate level, they can start learning the theoretical basics, architecture details, installation, configuration, code on the server, impact of different types of configuration on different types of hardware infrastructure, cluster infrastructure, like that. Then there should be some advanced level, like how to optimize the code, some kind of, let's say, some specific tools code for specific hardware infrastructure or specific cluster, how to optimize the data structure, all those things they need to learn. But, and also there are some professional needs which are like really project-based learning and consultancy. They are also looking for their own learning needs. So how to cope up with this? So there should be some, this type of demands will always be there, because there are variations nowadays. Actually, we are facing this type of challenges. So what we need to do is, so previously what we used to do, like there are like, let's say, when we are taking all these learning things to these software or middleware, like there are like programming related issues, like there are lots of programming language like Python, R, Java, C++, JavaScript. And then there are like Hadoop stack is there for big data stack. Like there are lots of Hadoop related things. And also there are like IBM's Power AI stack, which is really great for, which is like doing lots of different, addressing lots of machine learning related issues. So there are a lots of different software tools, and the which is making the situation more challenging is to mapping the students' demand with these all these different type of software tools. And the another level of challenge is all these things have different type of implication on different type of hardware infrastructure and on different operating system. So so far, whatever learning process have been done, they just focused on these two things, just the learning and then the software and middleware. But nowadays, what we can do, which can revolutionize and which can make the learning experience really better, is a Docker-based container. So here actually we can do like OpenShift and containerize all the learning solution, just like this, like the learning repository, hardware and optimized images, and then provide just as much that is required to the student. And then we can provide different type of infrastructure where the students can really learn their things. I mean, learn their all the needs. And also there is a huge growing demand, like how to separate out the data computation with data, so that student can get like 100 gigabytes of data kept in the same infrastructure, and through the Docker infrastructure different students can utilize the data for different types of learning. So, and these Docker images should be like platform optimized so that the student can learn more about like IBM Power 9, Power Cloud, and all these different types of like NVIDIA GPU, Intel cluster, Amazon Web Service, so that they can learn all these different types of things. So that is why we need a collaborative platform, and that is what exactly Onstitute can provide. So before, just here are some use cases, like I have collaborated with some academic institute, like students who wants to learn new topic in big data and AI, instructor can refer to use this site and all these things. There are several folks in industry who actually are interested to learn different data science related topics. Sometimes it is like because of their new project, sometimes it is because of their own learning needs, and something like that. So here with Onstitute online platform, we are actually collaborating with both different types of organizations. Like the first one of the project is genomic error correction, which is totally an academic research based project, where the HPC cluster was shared by all these universities, and then there was lots of publications and all these things going on. The next is we have a collaboration with another university which is situated in Kolkata, India. So we have collaborated for a blockchain based healthcare research. So where actually we had lots of cluster in many different places, and we actually created a blockchain network to share healthcare to test our healthcare interoperability. Now, the best part was it was started as an educational project, but suddenly we got lots of different outcomes and everything. And recently we have published a paper on JMIR, the Journal of Medical and Informatics Research. And also, not only these university project, many, as I told, there are several industry folks actually getting some benefit from this Onstitute. Like there are some folks who is working on Arista Consulting, and there are some folks from Deloitte. So they collaborated with some university students, and in a fun-filled way, they are learning like different types of things like classifying frames, image analysis, NLP, time series analysis, and all these different types of things, just according to their need. So now the thing is, when I'm talking about all these things, so now it's a time for a demo, how everything looks like when it comes to a really in the real practice. So the real practice is basically a website where you can register, and this is, I'm going to show a demo, and here this is the homepage for the website, and the name of the website is onstitute.academy. So whenever you will type www.onstitute.academy, you will land in this page. And here I am going to show you the experience. So once you will go to the courses page, you will see lots of different courses here. And then let's select this big data. And this big data will take you to the big data course. And here actually you have to register. So here you can actually register your name and email ID. That takes just like a few seconds. And once you will click this button, it will start the video lectures. And now these video lectures has different type of lectures you can go through based on your learning needs. And let's go to these TensorFlow. This video so let me just switch it off, switch the sound off. So as you can see here, actually, this is a big data 100 level course, and 200 level course is coming soon to take care of the students who need some more about configuration and all. And the best part is the student, while watching the video at the same time, they can learn with their on top of different infrastructure. So for example, for this course, actually, we got the infrastructure from U Oregon, and this is basically a Power 9 infrastructure where the students can really write their code according to their need. So let's say like import TensorFlow as TF, something like this. So, I mean, they can write any type of things. And the best part is they are really doing it on a very high performance computing infrastructure. And they really do not need to do only theoretical learning, but they can learn on top of like world-class power architecture or any type of architecture. Like here, if you just click on this hardware button, you can see lots of all the infrastructure and everything. And not only that, sometimes in industry, it is required that you have to do the performance analysis for different type of data analytic tools, and then select it on different, and then select the best tool for the next project so that the customer is happy. So there you can do something like, so far I was on a Power 9 based cluster. And here, just by a single click, you can directly go to an Intel cluster, which was actually given by, contributed by the UW Platteville, that is my university. And there you can check the performance. Like, let's say you have a heavy TensorFlow workload and you want to change, you want to check the real performance on different infrastructure. So I'm not sure what is happening in here anyway. So no, oh, I'm sorry. So this is like import. So here, if you just run it, so here, if you, so there is some kind of syntax error. Okay, as TF. All right, so these are the several things students can get, like really great hands-on experience and compare different types of performance implication of different hardware infrastructure, like Power 9 versus some Power 8 or NVIDIA GPU or whatever they want. And if the students do not want to do on the supercomputer, they can download our Docker image. Just they need to fire this command from here on their machine, and they need to have the Docker installed on their machine, and then just click on the connect, and it will connect to their local machine. And inside this local machine, they can do something with their Python code. And here also everything is installed, like TensorFlow and all these things. And not only these, they can also like change to their terminal, where they have like not only these machine learning tools, they can learn about like Hadoop, and all these different things are already installed. So let's say like PySpark, and everything is installed in those Docker images. And these Docker images are really optimized for different type of infrastructure. So we have our own Docker repository for that. So that is about the demo. And here actually you can find the hardware infrastructure, setup details, and all other links and everything. And so now let me go back to the presentation once again. So here actually, so this is what an Onstitute is. So so the future goals is like collaboratively improve the AI and learning infrastructure of the data, as I have shown, and irrespective of the geographical boundary, spread the data, AI and HPC education across the world to meet the global demand for quality data experts, so that there is no gap between the data and I mean the job demand as well as the educational, the labor supply from the educational institute. So if you are interested to work on this type of project, like if you have any data learning question, want to see any course on specific topic, or if you want to do some collaborative project with existing partners, you can contact me. And if you are interested in designing innovative courses and all these things, like for example, like GPU on OpenPOWER or power-based architecture, which I'm really looking for collaboration right now, you can reach out to me and just feel free to send me an email. And also if you want to educate the people or market your own software or hardware infrastructure so that you can reach out to a broader community, you can contact me. And also if you're starting any venture like data literacy or something like that with our infrastructure, OpenPOWER infrastructure or power-based infrastructure, please contact me. I'll be happy to collaborate with those things. And so there are lots of opportunities for which we can use Onstitute. I'm really interested to collaborate. So, and finally, this is what I want to announce. As you have already seen, I believe, in the website main page, I'm going to launch Onstitute on October 15 with 10 different 100 level data science course. And so stay tuned. And well, although it is October 15, but you can always contact me. It is always available for the beta users. So if you have any course in mind, and if you want to test the platform, if you want to use it for your students' class or in your industry or for any type of reason or for own learning purpose, it is always available for the beta users. So please feel free to contact me at my email address in here. And I would really like to thank OpenPOWER Foundation, IBM, MapSys for lending their resources, and also Raptor Computing System, and also these universities like University of Wisconsin-Platteville, Louisiana State University, Oregon State University for letting me use their resources. And that is it from my side. So any question?